Hello everyone, welcome back to my channel. This is a video on DevOps Engineer Interview Questions Part 5. So let's start. Question number 1. Describe a time you solved a critical production issue. You can answer to this question as, in my previous role, our production environment suddenly experienced high latency, impacting user experience. I quickly identified that a recent deployment had caused a database connection issue. I rolled back the deployment to the previous stable version while simultaneously working with the development team to fix the bug. We implemented additional monitoring to catch similar issues earlier in the future. The quick rollback restored the service, and the collaboration with the team helped prevent similar incidents down the line, ensuring minimal downtime and improved reliability. Question number 2. How would you design a scalable web application? You can answer to this question as, to design a scalable web application, I would focus on these key aspects. First is load balancing. Distribute traffic evenly across multiple servers to prevent overload on any single instance. Second is follow microservices architecture. Break the application into smaller, independent services that can be scaled individually based on demand. Third is auto-scaling. Use cloud services like AWS or Azure to automatically add or remove instances based on traffic. Fourth is caching. Implement caching strategies like Redis to reduce load on the database and speed up responses. Fifth is database scalability. Use a scalable database solution like replication to handle increasing data volume. Sixth is CDN. Use a content delivery network to serve static assets quickly from geographically distributed locations. This approach ensures that the application can grow seamlessly with user demand, ensuring performance and availability. Next question is, what factors do you consider when designing for high availability? The answer to this is, when designing for high availability, I focus on these key factors. First is redundancy. Deploy multiple instances of services across different servers or data centers to avoid single point of failure. Second is load balancing. Use load balancers to distribute traffic evenly and ensure no server is overwhelmed. Third is auto-scaling. Automatically scale resources up and down based on traffic to handle spikes without manual intervention. Fourth is failover systems. Set up automatic failover to backup systems in case the primary service fails. Fifth is data replication. Ensure databases are replicated across regions to maintain data consistency and availability. Sixth is monitoring and alerts. Implement real-time monitoring and alerting to detect and respond to issues quickly. These practices ensure that the system remains accessible, reliable, and resilient even during the failures or high demand. The next question, explain how would you troubleshoot a failed deployment? The answer to this question is, to troubleshoot a failed deployment, I would follow these steps. First is check the logs. Review application and system logs to identify errors or issues during the deployment. Second is verify the environment. Ensure the environment, that is server, database, or network, is properly configured and matches the expected setup. Third is rollback. If the issue is critical, quickly roll back the previous stable version to minimize downtime. Fourth is review CI/CD pipeline. Inspect the pipeline for failed steps, misconfigurations, or missing dependencies. Fifth is collaborate with teams. Work with developers and other team members to identify the code-related issues or infrastructure problems. Sixth is test locally. Replicate the issue in a test or staging environment for better understanding and fixing the root cause. By systematically identifying the cause and taking corrective actions, I can ensure faster recovery and prevent future issues. Question number 5. Describe a situation where you had to make a trade-off between speed and quality. You can answer to this question as, in one project, we had a tight deadline to deliver a critical feature. To meet the deadline, I had to make a trade-off between speed and quality. We decided to prioritize speed by deploying the feature with minimal testing and basic monitoring in place, but with a clear plan to improve testing and scalability and stability post-launch. After deployment, I worked with the team to quickly address any issues that arose and implemented additional tests to ensure long-term reliability. This approach allowed us to meet the deadline while still ensuring quality improvements soon after. Question number 6. How do you ensure compliance in a DevOps environment? You can answer to this question as, to ensure compliance in a DevOps environment, I focus on first is automation. Automate security checks, code quality, and configuration management to ensure consistent compliance across all environments. Second is infrastructure as a code. Use tools like Terraform or Ansible to define and manage compliant infrastructure, making it easier to enforce policies. Third would be regular audits. Implement continuous monitoring and automated audits to track the compliance in real time. Fourth is security best practices. Integrate security tools into the CI/CD pipeline to catch vulnerabilities early. Fifth would be documentation and reporting. Maintain clear documentation of the processes, configurations, and compliance standards for easy audits and reviews. By embedding compliance into DevOps workflow, I ensure security, consistency, and regulatory adherence without slowing down the delivery. Question number 7 is, what is the significance of a service level agreement? You can answer this question as, a service level agreement is a contract that defines the expected level of service between a provider and a customer, outlining performance metrics like uptime, response times, and support. In a DevOps context, SLAs help set clear expectations for reliability and availability, ensuring both development and operations team work towards common goals. SLAs also guide incident response times and help track performance, making it easier to identify and address issues that affect the service quality. Question number 8. What are some of the challenges that you have faced while implementing DevOps practices? One way of answering to this question could be, one challenge I faced was getting different teams, development, operations, and security to align with DevOps practices. There was resistance to change, especially around new tools and automation. To overcome this, I focused on clear communication, training, and showing the benefits of automation, like faster deployments and fewer manual errors. Another challenge was integrating legacy systems into the DevOps pipeline. I tracked this by gradually refactoring old systems and incorporating automated testing and CI/CD pipelines step by step. This approach helped smooth the transition and ensure continuous improvement. Next question. How do you keep up with the latest trends and technologies in DevOps? You can answer to this question as, I stay up to date with the latest DevOps trends by regularly reading industry blogs, following key influencers on platforms like Twitter, LinkedIn, and attending webinars and conferences. I also participate in online communities like GitHub and Stack Overflow to learn from real-world situations. Additionally, I experiment with new tools and technologies in test environments to see how they could improve our processes. This proactive learning helps me stay current and apply the best practices in DevOps. The last question is, explain the concept of a service mesh. The answer to this question is, a service mesh is a dedicated infrastructure layer that manages and controls the communication between microservices in a distributed system. It handles tasks like service discovery, load balancing, security such as encryption and authentication, and monitoring without needing changes to the application code. Tools like Istio or Linkerd are popular examples. A service mesh simplifies complex microservice interactions, improves the reliability, and makes it easier to manage traffic and security policies across services.